Good morning, students. Last lecture we have seen about various stresses or types of stresses. Okay. Today we will see about the examples, means basic example on these stresses. Particularly, the examples on these basic stresses is not in asked in exam, but for your study point of view or clearing your idea, we will study the types of stresses, the numericals on types of stresses. Okay. We can see in here in example 1, a problem is stated that a coil chain of crane required to carry a maximum load of 50 kilonewton is as shown in figure. Okay. In figure, a crane chain of coil is shown with a force of 50 kilonewton tensile force. Okay. So what should we find the diameter of link stock if the permissible tensile stress in the link material is not to exceed 75 mp. Okay. So from figure, given P is equal to 50 kilonewton, which is equal to 50 into 10 raised to 3 newton, and the stress is given, which types of stress is given. So this is tensile stress. Okay. Because we are already seen that in tensile stress, two equal and opposite axial pull forces. Okay. Two equal and opposite axial pull forces is known as tensile stress. Okay. Therefore sigma T is equal to 75 MPa, which is equal to 75 Newton per mm square. Okay. So what should we find? We find the diameter of link stock. Okay. Suppose small d is the diameter of link stock in mm. Before that, we know that area. So this is a coil chain. Okay, means circular. Okay, means the area of this particular section is pi by 4 d square, which is equal to pi by 4 is equal to 0.7854 d square. Okay. You may also know that sigma t is equal to w upon a or p upon a. Okay. So put down all these value, you may get 50 into 10 raised to 3 is equal to sigma t into a, which is equal to, put down the value of sigma t is equal to 75 into 0.7854 d square, which is equal to 58.9 d square. So find out d square is equal to 50 into 10 raised to 3 upon 58.9, which is equal to 850. So taking under root of 850, you may get d 29.13, which is equal to, by rounding off, which is equal to 30 mm. Okay. You should do calculation particularly, and if any problem in your calculation, then please ask me. Okay. So let's move our second example. A cast iron link as shown in figure is required to transmit a steady tensile load of 45 kilonewton. Find the tensile stress induced in the link material at section AA and BB. Okay. You see a cast iron link as shown in figure with section AA and BB. Okay. With a tensile load of 45 kilonewton. Okay. Look at the in right side section at BB. Section at BB is given in rectangular section. The length of rectangular section 20 in width, 25 outer, and inner is 40. Okay. So given P is equal to 45 kilonewton, means 45 into 10 raised to 3. Okay. So firstly we calculate the tensile stress induced at section AA. Okay. So we know that the cross sectional area of the link AA is equal to A1. Let's suppose it should be A1 is equal to 45 into 20, means 900 mm square. So tensile stress induced at section AA is equal to sigma T1 is equal to P upon A1, because you know that sigma T is equal to P upon A, but here we can calculate tensile stress as both sections. So we can assume sigma T1 and sigma T2. Okay, put down the values, which is equal to 45 into 10 raised to 3 upon 900 is equal to 50 into 50 Newton per mm square. Okay, similarly, stress induced at section BB, so A2 is equal to, so 20 into 75 minus 40. Here 20 means section is rectangular. Okay, the area of rectangular is BD. Okay, so B here 20 and D is equal to 75 minus 40, because in figure is given that section at BB means 700 mm square. So similarly, tensile stress induced at section BB is equal to sigma T2 is equal to P upon A2. Okay, consider A2 here. Many of the times student may confuse or put down the value of A1. Okay, so do not like this, which is equal to 45 into 10 raised to 3 upon 700 is equal to 64.3 Newton per mm square. All students do calculations. Okay, while doing calculation, if any doubt, please ask me. Okay, thank you students.